this video, we'll be going to discuss weekly contest for 98th solution and its intuitions. So without any further ado, let's begin into the solution. And for just a reference, I have broken the video into two parts. So we'll be covering the question 1 to 3 in first part and the other question in the second part because the video gets lengthy and I have received some suggestions from the people. Okay, so yeah, I'll be coming up with the other video that will show the question number 4. So stay tuned for that. Okay, so let's read question number 1. And before we read the question number 1, the question number 1 and question number 2 are exact identical, just that there were difference in constraint. So we'll start with the optimized one for this question itself. So the question is smallest table index 1, and it states like you are given an integer array nums. Okay, so we are given integer array nums and an integer k, right? K is also given to us. And for each index, we defined its instability score as, for if the index is I, so we'll first find the maximum of nums if from 0 to I, including I is included, okay? And also find the minimum from I to n minus 1. So on the left, we'll find the maximum if I is the index. So 0 to I will find the maximum, and I to n minus 1 will find the minimum. And then that is what it is defined, maximum of here, this and minimum. And an index I is called stable if the instability score. And what is the instability score? It's the maximum of 0 to I, whatever is the value of nums, and then minimum of nums of I to n minus 1. And we subtract these values. And if the value is less than equals to k, we'll say it's a unstable, it's called stable. Okay. And we need to return the smallest stable index. And if there is no such index that is possible, then we'll return minus 1. Okay. And here we have nums is this and k is this. So if you see here, right, if you see like as in the explanation, right, at index 1, if you see, so index 1 will be this. So on the LHS, the maximum is 5, and on the RHS, including this, the minimum is 0. And so the difference will be 5 minus 0, which is equals to 5. Similarly, for index I equals to 1, the maximum is 5 up to this, and the minimum across this is 0, so 5 minus 0. If you take index 2, so the maximum is 5 and the minimum across this is 1, so 5 minus 1 is 4. 5 minus minimum across this is 1, which is this, right, at index 2. Now if you go to index 3, right, if you see right this, the maximum across this is 5 and the minimum across this on the right is 4. So 5 minus 4 is 1, which is in our range, k less than equals to 3. So yeah, 1 is less than 3, hence the minimum answer is this. So that's the same way. And let's read the constraint first. So nums of length is 100 and nums of I is 10 to the power 9. So we don't need something like long. We can go with it, but not required. And then we have given k, right? So for this question, what we could have done is we could have gone with a brute force approach, since this is this. So I'll explain the solution as well. So let's go to the intuition first. Okay. So what will be my intuition? Okay. Let's wait for it to reconnect. Okay, it's connected. Okay. So let's say this is our nums, right? Our nums array is given to us, right? Let's say we are currently at this index I. Okay. Index I. So for this index to be stable, how do I calculate the instability score? If it is instability score, right? So to know the instability score, what do I need? I need the value of nums from here to this, up to this. What is the maximum value? Maximum across this. And I also need the value across minimum of this. Okay. And then answer will be max minus min, right? So the for the question number 1, right, since it is given that the constraint n is max 100, right? So in that case, what could I done for every index? Right, I will first run a loop from 0 to I to find the maximum, sorry, and then I will run another loop to find the maximum. This is n minus 1 to find the here minimum, and then I can do, right? So how much time will it take? I'll run first loop, for loop for this index, and then I will run another 2 loops to find the maximum and minimum, right? I'll just find 2. Okay, I'll find 2, and it will take again of n, and this will also take of n. So this will be of 2n, and this will be O of n. So O of n into O of 2n, which is O of n square in worst case, which will pass the constraints in n is 100, right? So this could have been done for the question number one, but if we want to find the optimized approach, we can go ahead and not instead of running this loop, we can reduce this, right? So what I can do is I can pre-compute, right? For every index I, what is the maximum value till this index I, and similarly on the left we can find what is the minimum value from n minus 1 up to this index I, right? So what I'm going to do is I'm going to do pre-compute it. So I'll first do what? I'll store one vector which will be storing the min. So let's say I'll say mini. So mini of size n, and what does it represent? So represent the let's say first we'll calculate the maxi, right? Maxi. So max value at max value, right? For index I, I'm calculating for index I, it stored max value from 0 to I, that is nums of 0 to nums of I. What is the maximum value? So I will store first one thing is this. The second thing that I'll run a loop from 0 to I n minus 1. Like the second thing I'm going to do is store another vector, that is vector of integer, and it will store the minimum. So it will store the minimum across from. So what it is do at index I, what it will store? It will store the minimum value from n minus 1 to I. So that is nums of I to nums of n minus 1. What is the minimum value that we can find in this given range? And once we have this, right, for every index I, what can I do? Answer will be maxi of I minus mini of I. And if this value, and if this value, whatever value we got, right, this is the value. If this value is less than equals to k, I'm going to return index I, right? And if at the end, even if I'm not able to find, then I'm going to return minus 1. So I hope the intuition was clear. So this suffice for both question number 1 and question number 2. So we are pre-computing so that we don't need to go ahead for an extra iteration that we can do in the brute force. So let's jump into the solution now. It's pretty simple. So as I discussed, right? So one is maxi, that is we're storing integer min, because every time we store maxi, we'll say integer min. That's the standard template that we have. And for mini, we store integer min, right? So what I'm going to do is for the very first time, I'll store the maxi, the first this thing, right? This one maxi. So maxi of I is maximum of at index I is maximum of index I and nums of I. And if this I is greater than 0, this is nums of I minus 1. So it's basic like prefix calculation, like what we do in the prefix. So it's just normal we can do. And this is similar, like, but we're iterating from n minus 1, and then we are going in the reverse direction, so that if I'm here, I know the minimum is 4. If I come here, I know the minimum till this index is 1. If I come here, it says 0, and if I come here, it will say minimum across this indexes across minimum at index I equals to 0 is 0, right? Because 0 is here is the minimum value. So once I have these two values pre-filled, then what I'm going to do is I'll just iterate over the loop, and I will find minimum, which is minimum of I, and maximum is maximum of I, maxi of I, and then I will find a difference. And if this difference is less than equals to k, then I'm going to return I. And if it is not, if we're not able to find anything, so we'll return minus 1, which is the edge case that they have given. If you're not able to find any solution, then we're going to return minus 1. So yeah, that's pretty much it for this question. So let's submit it, and well, I've already submitted it, but yeah, this would pass. Okay, so this is the same question as question number 2 as well. So here the constraint was 10 to the power 5, right? So uh, this suffices, because we the overall time complexity that you see is, right, for calculating this O of n, this is O of n as well, and this is O of n, so O of 3n, which is roughly O of n, if you can say, and n is 10 to the power 5, so this will pass. So if I show you the brute force, right, for Q1, I can show you this, right? So for every index, I will run a loop to find the maximum, and for every index, I will run a loop to find the minimum, and at the end, I will calculate the difference. So this was a brute force that will pass for of n square anything, but it will fail for of n equals to 10 to the power 5. So that's why we come with the optimized approach. I hope that's understandable for all. If in case if I find any issue, do let me know in the comment section. I'll revert back to you. Okay, so now let's go to the third question, that is the multi-source flood fill. So if you have done rotten oranges or something, the question was similar to that. Okay, and let's read the question. You are given an integer, two integer n and m. So basically states like if n and m, so it's the matrix of grid n cross m, right? And then we are given a sources where it says like sources is of the format ri, ci and color. So it says at row this row I and this row column I, that is that this position in the grid, the color of this is I, color I. Okay, and all the other color will be 0 initially. So what it says is like at every time, let's say if you are starting at here, right, uh, at every step the currently colored cell spreads, so it will spread in the 4 direction. So if you see here, right, it is 0, it is 1, right? So in the next 1 second it will be here, it will become 1, here it will become 1. So that's how it was given 1 1, and similarly the 2 will become 2 and 2. In the next 1 second the every neighbor cell will become will be the same value, right? So this is flood fill. If multiple so this is the main part of this, otherwise it would have been a cakewalk, or like we didn't need anything. There was such implementations. So this was the only some cases that they have had, like if the multiple color reach at this same colored box, like let's say if you see here, right, so in the next second this one will try to make it 1 and this 2 will try to make it 2. So it is said if multiple colors are trying to make it same reach at the same time, then in that case the color with the maximum value will be filled. So out of 1 and 2, since both are reaching at the same time, so 2 will be given more priority and it will be filled with 2, right? And this process will continue until no more cells are left uncolored. So we need to return the final state of the array, right? So let me explain with this one. I will take this and go back to our whiteboard, right? Let's see. Let me have it. Okay, so at the very first second, right, this was given. So this was our state at initial time t equals to 0, and in the next second, so we say we have made it at 1, and at time t equals to 0 we made it at 2, this 2, since it was given to us. If you see, right, this one, grid 0 0 is filled with 1 and grid 2 comma 2 is filled with 2. So that's the sources, that's what indicated, right? So next second what will happen at time t equals to 1, this cell and this cell will be filled with 1. If this was there, then this would have been as well, but it's not there, so it won't be. And for t equals to 2, this and this, right? So this are out of this even out of box. So this one and this one is filled with 1 and this are filled with 2. Now let's go and see what happens. So okay, so right, so this one at next second it will try to become this and this, this and this, but this is already done, so it don't, and this is already out of box, right? So this one will make this and this, but this is already done, this out of stop and this. Okay, so if I try to make erase it, and so what all is the actually trying, it's trying to make this and this as 1, it's trying to make this and this as 1. Okay, but at the same time if you see, right, 2 is also trying, here we have 2, right, this 2 is also trying to make it 2, and this is also trying to make it 2. Similarly this is also trying to make this as 2 and this is also trying to make this as 2. So if you see at this index, both 1 and 2 are trying, and at the same time instant, right, t equals to 2 second, right? So here the value will be overridden by the color which has more value. So 2 has more value than 1, so hence it will become 2 and not 1. Similarly here if you see, it will become 2 because both 1 and 2 are trying, and since 2 color is more is higher in number, that is why it will become 2. Similarly here also it will become 2. So the final will look something like here 2 2 2 and rest all 1 1 1 and 2 2 2. So this is the final answer. So I hope this is clearing. So the only I think you have done this similar question which is rotten oranges or something like that, or flood fill, this multi-source BFS, but the only difference is like if two colors are getting filled in a cell, if two colors arrive in a cell at the same time instant, let's say this and this, then the color which has the higher value will be dominant, and the color which has the lower value, it will stop, it won't propagate. Okay, it can't be filled here. So I guess it's better, I guess the question is understandable, and we are ready to move to the intuition. So what I'm going to do is, so since we see, right, this is like spreading one step. So what I could do is I can try BFS, right? And how did I know like BFS? Because if you see like whenever we are given like filling, like, right, so in that case we need to move one step, right? So we are going for BFS. So the intuitions will be clear why BFS is actually used. Okay, so once we know like, okay, we're going to use BFS because it's type of a flood fill, and now the main challenge will be like, how do I know like if both are reaching here, then how do I know which color will have more priority? But I should know like, okay, so there is one thing like I need. Okay, if both color are reaching at the same time, uh, so I can see like I need one visited area or something, or you can say distance, like distance of index and this. So what is the main issue that we are facing, right? So see, if two colors, uh, so I'll write down the main issue that we need to address. If two colors reach at same time, right, this is the only case that we need to consider, right? Then take higher value color, right? So what else do we need like to implement this? What is the major requirement from our end? So if you see, right, so we need to know at this index if some color is reaching, right? Let's say row, and this is column. So if at this index some color is reaching, let's say this red, this color red is reaching, right? Let's say this pink color is reaching this row. So we need to know how many what is the time it has taken. So let's say it takes 3 unit, and let's say some other color like brown, it has reached here in 2 unit. Okay, so even if 3 reaches here, we know that this the time matters, right? So this will be only taken into consideration when it's the same time. So if 3 reached but brown reached in 2 units, and let's say pink reached in 3 units, irrespective of if they have if pink has a color, let's say color value of 5, and this has a color value of let's say 1, but since the time it has taken is less, we'll consider this one. So I need to know at every index what is the first time a color is reaching. Okay, so that if a color reaches the next time, and it has a and the color reaches if a cell is already colored, then whatever color reaches with whatever value, we are not going to consider it. So that is why I need a distance which will say distance of I is a uh, minimum time at which a color reached. So it will say minimum time at which a color uh, at which this index is colored. Okay, and minimum time at which this index is colored. Okay, so this is the one case. Now the second case is, let's say this also reached here in let's say the second case was, okay, let me have this. Okay, let's say this is the second case. Okay, and in this case what we have is, let's say even pink it reached in the time instant of 2, right? In this case, if it reached at time instance 2, so I'll have answer, right? Answer, or I will say what is the color that I have. So color of index I and j will store what is the color of this grid. Color of this grid, right? So let's say if two colors have reached at the same time instance, let's say we have covered for at index I and j, the color is pink. Okay, let's say the color is brown, so I will say color is brown, that is 1. Okay, now next time when I say, okay, pink has reached the index I and j in the same time instance, so for this the color will be 10 and the distance ij will be 2, right? Since it has reached in time instance of 2 and the color will be 1. Now when I see pink has also reached in the time of 2, so the distance of pink will also be 2. And when I see, okay, the color is lesser In that case, I will make the color, I will increment the color because we need higher value. So these are the only two conditions that we need to take in mind. Okay, I hope that it was clear. Let's with the example, let's just run into the solution that we'll be doing. Okay. So initially I solved it using a priority queue, but I think a priority queue was a overkill and we don't need it. So I will be implementing, I had implemented with a BFS as well. So, okay. So this is a vector. So answer, right? It will say, what does it store? It stores like uh, grade of I, J is filled with which color? Which color? Okay. So it will say our answer grid is filled, answer grid ij is filled with which color. Okay, and this is our queue. Okay, and this is our distance, so it will say uh, distance of ij, minimum time in which this grid was covered, this index was colored. Okay, so it will say, okay, so now what I'm going to do is I will take a queue, right? I'll take a queue, and in this queue I'm going to push the distance, which is 0. I mean distance, or it will say time. The time I'm pushing as 0, and this is the color that we have, and this is also next comes is like index, row and column I and j. Okay, and at the end in answer I will say, okay, this grid is covered in this with a time of 0. Okay, even though we don't need it, it can be done. Okay, since this was covered. Now we're gonna go into this. Okay, we're going to go into this. I will run a loop. Okay, I will take out elements from the queue, just do a BFS, and this is the main condition that I have been talking about, right? If we see if this distance, if this row is distance of this row and this column, if you say it's 2, right? So if it this index, if you reach, right, if you reach at 2, if you reach, let's say this, it says this cell was covered in two place, in index equals to 2, distance equals to 2, so 1 and 2, like this, right? And let's say if some other color which was from here, hypothetical case, it was reaching here at and it took 3 units of time. In that case we are going to ignore it because we already there is already a color that has reached before, and we can't overwrite it. And the second case is the color, both the color reached at same time. So one also, this also reached here at 2 time equals to 2, and this also reached at time 2 equals to 2. If both reach at same time, and then we're gonna see if the color that was filled, like if one reached here and the color was 1, um, that means 2 can come. But if 2 reached here before, and now we are calculating for 1, so we see 2, it reached at the same time, it has a lower color, then we are going to ignore it. So this is the case for this. Else we are going to store the distance, like what is the time taken for this grid to minimum time in which this index was colored. So we'll store the time, and then this will store the color of this grid, answer of this grid. And once I'm here, like let's say this is here, like I'm here, I'll go for all the other 4 rows. I'll go for all the other 4 rows here, and I'll find a new row. So the move a distance like up, down, left, and row, right? And we'll see if this is in the range, in the grid. If this lies in the grid, I'll say, okay, let's say if it comes here, okay, and we see, okay, this grid, or let's say here, right? So if you see, right, this grid, it will go one distance here, here, and here, right? But if you say this was already covered in time equals to 0, and now if we go like this took 1, and again if we go, it took 2, it takes 2, right? So if you say like if the distance of this new x and new y, it is greater than distance plus 1, so it has already been reached in a previous state. In that case, we are not going to do. But if it has taken more than time, then we are going to cover this case, right? And else, the else case will be if the distance it reached is same time. So 1 reached here at time 2, and 2 also reached at time 2. But if you see the color 2 is more dominant, so either case, like if it has been reached in a smaller time, or if it is being uh, colored with a higher color, in that case we'll color it and we'll push it in our value, right? And at the end we'll return the answer. So this will just fill it, and this will fill until all the grid is covered. So I hope that answers And in case if you have any doubt, do feel free to reach out in the comment section. I'll be happy to help. So I think that's pretty much it for this one. And for question 4, I will be carrying out a new video because it will get too lengthy. So stay tuned for that. And if you have any doubt in the first 3 questions, put down in the comment box. I'll answer it. And I'll be also answering the putting the solution in the description. So that's all for this video. Thank you.